In this video, we're going to talk about volume. So we're going to talk about how to calculate the volume of 3D shapes, and we're also going to talk a little bit about how to convert between units used in 3 dimensions, 3D. So volume is just a measure of how much space an object takes up. So we'll start by thinking about this little example here. We've got 2 rectangular prisms, and they're made up of 1 centimeter cubed blocks. So 1 centimeter cubed block just means that each of these blocks has 1 centimeter on its, each length, every single length. So even the depth, the height, all that, they're all just 1 centimeter. So if we want to work out how many cubes make up each layer, well, it's pretty obvious, say on this one, the top, you've got what, 2, 4, 6, 8 blocks for that top layer, and you've got 3 layers. So what? So we've got 8 on the top, 3 layers. What would that be? It'd be 24 blocks, right? So it'd have a volume of 24 centimeters cubed. That's how much volume it takes up, right? So centimeters cubed, one of our units of volume. Likewise with this one, we could think about it in terms of the layers, kind of, you might say standing upright, standing vertical. So we've got what? 1, 2, 3, 4, 5 along the top. 1, 2, 3, 4, 5, 6. So you think about, seeing as it's 5 by 6, each of these layers is going to be 5 times 6 in terms of its kind of area here. So that's 30 blocks, and you've got 2 of them, so it must be 60, right? So this must have 60 centimeters cubed as its volume. So what we've done here, right, is we've thought about, well, how much area does this one take up? And we've times it by the height. And this one, we've gone, all right, yeah, how much kind of area does this one take up? Times it by the length. It's worked for both. So to calculate volume, what we do is we think about how much area is taken up by a cross-section of a shape. Often it's the base, but not always. And then we think about how many of those areas would you need to stack on top of each other to make the whole shape. So if you think about, say, a 3D shape like a building, you can think about the area made up by, say, the floor, just the base. And if you stacked each of those floors on top of each other, you would have the volume, the space it takes up. But alternatively, because this is a rectangular based prism, we can also do the vertical, right? We could think about that vertical rectangle, that big one, and then stacking them backwards, right, along the length. So the formula is always just area times height or perhaps length, right? You're just thinking about stacking them on top of each other. So it's like if you had to make a cube, it's like pieces of paper, right? If you had lots of the, effectively 2D, the pieces of paper, you stack them on top of each other and you get a cube. And we use things like cubic units, cubic centimeters, for example, to measure volume. So we'll think about this example first. Have a read of that. Maybe even give it a go by pausing the video. I'm going to do it here. So first thing I'm going to do is draw it. I'm given a picture there of the actual building, but I want a diagram for myself. So, that is one wonky building. There is some not so good engineering happening here. So here it is. Okay, so we're told it's 80 meters tall, so we can put in 80 here. And we're told what, it's 20 meters wide, so maybe 20 up here. And it's 50 meters long, so perhaps 50 over here. So here we've got a bit of a choice. We can do it however we like. What I'm going to do, so volume is kind of area by height or length. So you could say V equals AH, like A times H. I'm going to get the area of this face of our 3D shape. I'm going to times it along this length. So the area of that would be length times width. And we're going to times it by 50, that kind of length along there. So it's 80 times 20 times 50. So ultimately, we're just timesing everything together. Seeing as, with timesing, it doesn't really matter the order you do it in. Maybe the way I'll do this actually is, I know that 20 times 50, or 2 times 5 is 10, right? And I've also got the extra zeros left over. So I'm doing 80 times 1,000, which is really just, so we keep those zeros as well. So 80,000 meters cubed. So yeah, it's a big building. It fits a lot of stuff. 80,000 meters cubed worth. Let's have a look at another one. We've got a swimming pool. Maybe give this one a go and then watch me do it in just a moment. Here, if we think about it right, the only cross section that is going to be the same is the one that's shaded down here. if you think about, if you were to cut this shape, say through here, that's going to give you a different cross section than if you cut it, say, through here. So we've got to use that base. It's the only cross section that's the same, the only cross section that we can stack on top of each other and make ourselves our volume. So we're going to do the volume is area times height, and it's 15.5 times 10. So it's just 155 meters cubed. Now it says to give you answers in liters. We might do this in a sec. So we'll just give it in meters cubed for the moment. But yeah, that is one measurement of the volume. Pretty okay. So in terms to get things into liters, you've got to be able to do volume conversions. What I do is I'd have a look at this diagram and see what you notice. I think the thing I notice is I know that if I go with just regular millimeters, the unit of length, to centimeters, well, I've got 10 millimeters for every centimeter, so I divide by 10. The difference here is with our cube units, instead of dividing by 10, we divide by 10 cubed. That's to do with the dimensions, right? We've got extra dimensions happening here, so it's actually, you need more of these units to fill up the next one up. And this is the same for all of them. So what I would recommend is just knowing your unit conversions for length. And then when you're doing volume, you know that everything's cubic units, right? So your unit conversion factors are just cubed. So either if you're doing it by hand or with a calculator, you've got to cube your conversion factor. Another thing that comes up a bit, especially when you're dealing with things like, water, milk, things like that, is liters, right? Well, I would suggest just memorizing that 1 liter equals 1,000 milliliters. If you speak French, that will be relatively easy because mille in French means 1,000. So you've got 1,000 milliliters in a liter. And then the other thing that makes it easy if you wanted to go from these units to liters is 1 centimeter cubed is exactly the same as 1 milliliter. Very nice. So we've got some conversions to do. Let's try them. So we're doing 2 meters cubed to centimeters cubed. Just do it down here. So we've got 2 centimeters cubed. We want to go to meters cubed. So what I'd go is all right, I think about it. All right, normally centimeters cubed. So normally centimeters to meters, I would need to divide by 100, right? There's many more centimeters in a meter. There's 100 centimeters in a meter. So if I have centimeters, I have to divide by 100 to make it the amount I've got smaller, right? It's a small amount of centimeters. It's not going to be an even smaller amount of meters. But we're dealing with cube units, so I've got to do cubed. So in your calculator, there'll be a button that looks something like this, X, and then a little box here. So this is saying if you press this button, you'll get a box to put something in that little box there, an index, right? So you could press 2 divided by 100, press this button, it'll take you to that next level up. You put a 3 in there and it'll do it for you. If you wanted to do it by hand, the way I would think about it is you're 2 divided, well, 100 cubed. It's the same as just dividing by it 3 times. So if I have 2, I'm just going to write lots of zeros either side. So normally there's a decimal point there, right? If you've just got 2. If you divide by 100, you go once, twice, and you're here, yeah? We've got to do it 3 times because we're doing it by 100 cubed. So we go again, and we go again. And so there we have it. It's 0.000002 meters cubed. So we can see you need a lot of centimeters cubed to fill up just 1 meter cubed. Let's just do the final one. Oh, here it is down here. Let's do the final one below it. Why not? So 150 millimeters cubed to centimeters cubed. Oh, well, we mix this up. Let's change it just because we left up that last one. We'll call this is now centimeters cubed, and we're going to go to millimeters cubed just to show you the other way. So if I have 150 centimeters cubed, I know that it needs to get bigger to get to millimeters, right? Because millimeters are quite small. So if I've got centimeters, I'm going to have lots of millimeters. So I times by, well, normally I times by 10, and I'm timesing by 10 cubed. So all I'm doing, normally when I times by 10, I would just put another 0 on the end. But now, because I'm doing it cubed, I'm doing it 3 times. So it's that many millimeters cubed. Okay, I hope that was helpful and that you're feeling good about volume. Thanks very much.